Hello, welcome to the Introduction to Organic Chemistry lecture series. This is the chapter 2 and part number 4. So in this series, we will study about the weak acid and weak base and how we can determine their strength of for the weak acid and weak bases. So usually we use ionization ability to determine if the acid is weak or not. So what is the meaning of that? It means how easily it form a positively or negatively charged ion. Or we can also say how completely does an acid or base ionizes in the water or in aqueous solution. So as easily it can form, it will be stronger comparatively. So there are two terms, strong acid and weak acid. So strong acid means completely ionizes into ions, and weak means partially ionizes, and it results basically to form a equilibrium. So what is the strong acid? Strong acid means those acids completely react completely or almost completely with water or in aqueous solution to form hydronium ion. And strong base are those which react completely or almost completely with water or in aqueous solution to form hydroxide ion. So these are the six strong acids are the listed here: HCl hydrochloric acid, HBr hydrobromic acid, HI hydroiodic acid, HNO3 nitric acid, H2SO4 sulfuric acid, HClO4 perchloric acid. And these are the strong base. They are called the metal hydroxide. Metal hydroxide. So lithium hydroxide, sodium hydroxide, potassium hydroxide, and barium hydroxide. So they are all very strong. These are strong acid examples on this side. And these are the examples of strong base in the second column. So these acids and bases dissociate in water in aqueous solution 100%, almost 100%. Suppose you have 100 molecules of lithium hydroxide, it will almost dissociate 100 more to 100 or maybe 99.99% like that. But in case of some acids are not strong, so they are called weak acids, or basically organic acid and organic bases, they are also weak base. So what is the meaning of weak base? Partially dissociate in the water or in aqueous solution to form hydronium ion. Weak base are those which partially dissociate in water or in aqueous solution to form hydroxide ion. So this is the difference. Weak acid example, when we dissolve acetic acid in the water, basically it is a very weak acid. And in the equilibrium, it's a very small forward direction. Mostly it remain in the acetic acid form. So we can write like this kind of arrow. So mostly the equilibrium remain on the acetic acid side because only 4 out of 1000 acetic acid molecule dissociate in the water. So it's very, very weak acid. Next is weak base or example. So ammonia is a weak base when tried to dissolve in water. It have very slow or sluggish reaction toward the product side. Mostly it remain on the reactant side. So this again, so these are the examples of the weak acids. And they, based on the ionization, we have a list of the strong and weak acid. So how we determine? So for an example, we have seen this acid, acetic acid is weak acid. And if we can make a general reaction, general weak acid in water. So this is an example of general weak acid, right? Ha, H for hydrogen, A for anion. When it dissolve in water and it will make exist in an equilibrium, it will form an anion, A minus, and then hydronium ion. So we can write an equilibrium reaction equilibrium equation for this reaction, and which will be equilibrium constant A, Ka, or equilibrium constant for K in basically for the water. It would be the product of the um, hydronium ion and cation. So product concentration on the top and basically in the big parenthesis I will write divided by reactant concentrations. Reactant concentration. So what will happen here? You can see since acetic acid is very slow or very weak acid, so mostly it remain the higher concentration of the acid will be there and very low concentration of the product will be there. So upper value, numerator value will be very low and denominator value very high. Because of that, the weak acids, since weak acids ionization constant for the weak acid are number with negative exponent. Therefore, we often express this value in the terms of pKa value. So pKa, how we calculate when we got the K value, Ka from this equation, then we calculate the pKa. So pKa, if we take the negative log 10 of Ka, we will get the pKa value. This is exactly similar like pH calculation. If you will know the hydrogen ion concentration and you will take the negative log of base 10, then you will get the pH value. So this pKa value shows that if the pKa value is very low, it means it represents the strong acid. And if pKa value is very high, then it represents strong base. So based on the pKa value, we have this table number 2.2, and it represents that the some organic and inorganic acid strength. So here you can see on this column, the pKa value of the ethane is 51, and at the bottom, the pKa value of the hydrogen iodide is -9. So very low at the bottom, very high up on this side. So if a pKa value is very low, it would be very strong acid, and pKa value very high, it would be very weak acid. On the other hand, if pKa value is very high, then it will be considered as a very strong base, and if pKa value is very low, it will be considered as a very weak base. So as you can see here, ethane, ammonia, ethanol, water, ammonium, methyl ammonium ion, bicarbonate ion, phenol. So as you will go down, acidity will increase because these pKa value is decreasing. So the pKa value is more toward the zero or toward the negative number, it would be more and more strong. So this pKa value we use to determine our equilibrium, if the equilibrium will shift toward the product side or the reactant side. So let's find out the position of equilibrium for the weak acid and weak base, in which direction our equilibrium will shift. So there are some rules. Remember, we have to know how to calculate the pKa value first thing. And once we have the pKa value, remember this rule, if the pKa value is very low, then it represents the strong acid. Basically, I will write the red color. So red color means strong acid, and blue color means if higher pKa value, so higher pKa value represent the higher base. And so there are 5 simple rules we have to follow to find out the first. You have to find out identify 2 acids in both sides of the equilibrium. So this is the reaction we will work on this one. Use pKa value from table 2.2 to determine the stronger and weaker acid. So This is the one example is given here, that this is the pK value, and then as you will go from top to bottom, it will be strong acid at the bottom and weak acid at the top. So, and then we know that the stronger acid give weaker base and vice versa. And a stronger acid react with stronger base to give weaker acid and weaker base. So what will happen in these out of the four rules, we have to conclude that equilibrium will shift on the side toward the weaker acid or weaker base side, right? So for an example, if we have acetic acid and ammonia, so in that case, we have to determine in this reaction what are the two acids. So one is acetic acid, which is listed in this here. Another is ammonium hydronium ion. Sorry, this is the ammonium ion. This is the ammonium ion. Ammonium ion. And ammonium ion is listed here. And it has the pKa value 9.24. So pKa value 9.24. And here pKa value for acetic acid is 4.76. So 4.76. So this is a stronger acid. Stronger acid. And this is the weaker acid. Weaker acid. So stronger acid have tendency to donate proton. Donate proton. And weaker acids have tendency to accept proton. So in this way, we can say that our equilibrium will shift in the forward direction. Basically, this reaction will be go in the forward direction. So it would be more on the product side, more will be on the product side, then a small arrow will be on the back side. So thick arrow on the or larger arrow toward the product side, and then a small arrow toward the weaker side, toward the reagent side. So here I have some listed some more practice question. So use the table 2.2 to find out the acidic strength of pK and determine the which side of equilibrium of the following reaction will shift. So when the ammonia will react with the water, in which direction the equilibrium will shift? When carbonic acid will react with hydroxide ion, in which direction the equilibrium will shift? So try to practice these questions with your rule which you have learned in this series. So in the next video, we'll talk about something more about the detail for the effects on the equilibrium.